welcome. Today on the bench we have a specific products model WWVC standard frequency comparator, and what this is a WWV receiver that has functionality to pick up 25 megacycles, 20, 15, 10, 5, and 2.5 megahertz. These receivers are specifically for monitoring the time signal from WWV in Boulder, Colorado. And this would have been back in the 60s how you did frequency checks, time standard stuff. You know, we didn't have the satellites linking everything through GPS anymore, or then for doing time standard. It was all done through receivers like this. And there's filters here for ticks, 440 cycles, 600 cycles, voice, and compare. Now, I don't know what compare does. I haven't been able to find a specific manual for this. The owner said that he had looked and hadn't found anything. I have found a manual for a version of this. It's very similar. Oh, did I mention this is the guy that I just fixed the Yaesu for? And he asked me if I'd take a look at this. I'm busy talking here and I don't remember what I said. At any rate, this was the same guy I just fixed the Yaesu for. And when I dropped that off, he asked me to take a look at this. He also made several donations to the $10 test bench. And we'll be getting to those in later videos. He had an RCA oscilloscope he's donated. A bunch of early cell phones that we'll do a teardown on just to take a look at the technology from way back at the dawn of cell phones. I have not yet turned this on. He said he had at some point in time, and all it did is make noise. Now, before I fire this up, I want to take the covers off. I want to check a couple of capacitors, and then we'll bring this up on the Variac. It's in pretty good shape, with the exception of the front panel over here has a pretty good arc in it. It looks like this was dropped at some point in time on this panel. This is a rack mount unit. And I believe he said this was probably a dumpster dive recovery find. But it has an oscilloscope for monitoring the WWV signal and the time ticks. It has a built-in speaker. It's got a limiter. It's got AGC, gain and stuff for the scope. I haven't even looked at the manual for the other ones yet. I did download it. I did print it. But I haven't even gotten as far as looking at it. We'll do that later this evening probably. And up here there was a serial number or a... I forget what they call them when they put capital equipment. They put stickers on them. There's still a sticker on one side or the other. Or a stencil. Yeah, it's a sticker. There's a sticker over here with a capital equipment listing on it. But obviously this was decommissioned many, many years ago. This is fully tubed. There's no, as far as I know, no solid state things, nothing inside. I think even the rectifier in this is a vacuum tube, 5Y3, I believe. From what I've seen on the internet about the other models, it's crystal controlled. It only operates on WWV. It operates on multiple bands, but only for one specific radio station, and that's the Boulder, Colorado time standard. So let me get the covers off of this. Let me get it hooked up to the Variac and the current limiting and see if we can make it do anything. Okay, as Dave over at EEV blog would say, we've lifted her skirt and we peeked underneath here. And there's quite a bit of dirt and grunge inside of this thing. So the first thing I'm going to do is get the vacuum cleaner over here and suck up some of this debris. But on a quick perusement here, I've noticed very quickly this was probably built for the military. There's a spare panel lamp down here, all wired and ready to go. And all it has to be done is this panel lamp gets pulled off. That panel lamp would get plugged in and you'd have your spare panel lamp online and up and running. This is fairly common in military gear. Sometimes they actually have it on a turret. Sometimes there's a switch inside. But should the panel lamp go out, you can, within a few seconds or however long it takes to get the two screws and slide the cover off, you can have the panel lamp up and working again. The wiring in here has got that chalky white, moldy, deteriorated look that tells me this has been damp and in a damp environment. In fact, you can see that white crusty stuff on all of these wires, and that's actually a black wire. That was actually a red wire at one time. So I shouldn't be doing that without a face mask on. I'll go put a particle mask on, and I'm going to vacuum this thing out. We've vacuumed out about a pound of dust, probably accumulated over the last 60 plus years. And this is not the same interior, although the layout's very similar. This is not the same interior of the units that are in the manual that I downloaded. That was using octal tubes, things like a 5Y3 rectifier and so forth. Or at least that's what I think I downloaded. Okay. Hang on. This unit, the schematic shows a 5Y3 rectifier, which is obviously not here anywhere on this chassis. However, the tube complement in the schematic is virtually the same tubes. We got 6C4s, 6AL5s, 6X8s. They're all on the schematic. So this unit will at least give us a general operating theory of it, tell us what all the controls should do in general. There is, however, no 5Y3 in this unit, so I'm assuming this is a later unit and probably using solid-state rectifiers. So we'll want to take a look at this multi-part filter cap that's back here in the back corner of this thing. We're going to be very suspicious about that. The videos on YouTube show the underside of this as having lots of paper electrolytics also, which will have to go. I told the owner before I took this, it's likely going to need to be totally recapped. So I'll have to come up with a figure for all the parts and see if he wants to proceed. I don't want to throw $100 in capacitors in here and find out that he really wasn't that interested in the unit, although it's an interesting piece. So let's get the bottom off of this and see what we have. The voyage of discovery continues. We have the bottom cover off, and it's pretty clean in here. Reasonably clean. I did vacuum out probably 100 different spider webs from various places, and there were some odd looking chrysalises in here which now reside in the vacuum cleaner. Hopefully I won't have an alien hatching out in my vacuum cleaner tonight and murdering me in my sleep. The unit appears to have a very manageable amount or number of capacitors to be replaced. There's no 5Y3, of course, so we have solid state diodes as we expected to see. The schematic I have shows the power transformer, which is here, obviously here. We have our audio output transformer. I've traced that out. That's the audio output transformer. The schematic shows a separate filament transformer for the CRT. That's here. It also shows a separate filament transformer for the 6X4 rectifier, which is the high voltage rectifier, or they were using it for rectifying DC for the CRT. That does not exist. There is no 6X4 in this unit. That's probably these two diodes here. I haven't traced it out yet, but it's fairly obvious. We have a bridge rectifier here and two extra rectifier diodes here. It's more than likely these two are going to replace it. We have 3 electrolytics here, 220 microfarads at 150 volts, a 4 microfarad at 450. Those should be replaced just on principle if he plans on keeping this and running it for any length of time. We have a couple of 25 microfarad, 25 volt. Those are obviously cathode bypass. They could probably be left in, but they're not expensive. If we're going to be pulling these 3 out, we might as well change those. I see another one lurking underneath here, which is probably another cathode bypass. It's not going to be all that much more money. We have another 4 microfarad 450 volt mounted on the back of the CRT, and this had a cover over the top of it, which I removed to take a peek underneath and found that lurking under there, so that should be changed out as well. It'd be a shame to lose this piece of equipment for a a $5 or $7 capacitor that went short circuit on you. The 2 amp fuse over here is intact, so that's a good sign. Nothing's burned up. There's no sign of charring on the transformer. A little bit of rust on the clamshell, but that's not a big deal. The inside on the bottom looks very clean. The crystals should be inside of this housing along with the switches. I probably won't disturb that unless I have to, unless I find out that the switches are giving problems, and then I'll pull this apart and give it a squirt. But you've got to almost remove the box to get the cover off, and I'd rather not disturb that if I don't have to. Here's the bottom side of that same enclosure right here. I have a mystery unit right here, which does not appear on my schematic, but by tracking the wires, color coding of the wires, they go up to the front switch, the panel switch that says 400 hertz, 600 hertz, tick, audio, and compare. So I'm going to go out on a limb and say this is an audio filter block that filters out or peaks at 400, 600, and has a wide pass, band pass for audio. For the time announcements, I'm feeling pretty safe about that. What's this variable cap labeled here? On the front, that's tune. Okay, so it allows you to tune a little bit if the crystals aren't quite on frequency. There are trimmer capacitors inside the box according to the schematic, but rather than have to trim the thing every time it drifts a little bit, we have a little Collins 455 kilohertz IF filter down here, mechanical filter. I'm betting that's in good shape. Collins Radio made good filters. I don't think it's going to have the same problem those Yaesu filters did. And other than that, I think we've pretty much seen all there is to see. We'll get this thing hooked up to a dim bulb load and see if we can bring it up slowly. I'm going to very closely monitor the voltage on these capacitors right here. If one of these goes short, we could lose a power transformer or one of the dropping resistors that's on the back, and that'd be a shame. Whoops, we have a loose screw. And no, it's not me this time. Ha! For those, oh, that's just one of the screws holding one of these resistors in has backed down for some reason. Oh, you're not in the field. You're not in the... There we go. Come on, dumbass. Get everything in the frame. This screw has backed down for some reason. I'm wondering if somebody was in here working on it, or if it's just something that was overlooked at assembly. There, that's back pretty much where it belongs. We'll check the resistor out and tighten everything up as needed. Okay, let's get this hooked up to a dim bulb. Before we go too much further, I should show you the damage to the front panel here. You can probably see the gap between the panel and the chassis, and if I put a good straight edge on there, you can probably see there's a fair amount of daylight underneath the edge of the straight edge. However, the good news is the paint isn't damaged, and there's no kinks in the aluminum. I think I could fairly easily remove this panel and with some wooden blocks and the arbor press straighten that out so that you'd never know it was bent. That'll wait until we have the electrical restoration up or finished on this if the customer wants that. Once we have it up and running and everything working correctly, then we can go ahead and do those mechanical. Okay, the radio's hooked up. We have our variac. We have our current limiting up there, which is a 100-watt light bulb. Now this radio's probably going to draw a little bit more than that, or around that, but that's okay. This will get us started. We're hooked up to our filter capacitor over here, our main filter capacitor. There's 3 sections in series, or 4 sections. 4 sections in series. They go through dropping resistors up here. 3 dropping resistors, 4 sections. So you have the, and I'm on the final one. And if we turn on the AC, and I put about 10 volts of AC into the primary, and turn this thing on, we've already got 25 volts of DC on the filter caps. So that tells me the power transformer is working. There's no dead shorts. Our light bulb is completely extinguished, so we're not drawing any current to speak of. And if I shut off the radio, you can see the voltage does not drop, or does not drop very quickly. So the capacitors appear to be okay at this point in time. Now I don't want to smack these with full operating voltage right away. We're going to bring this up very slowly. Once the tube filaments begin to get warm, we're going to draw current. You should see the DC voltage fall off a little bit. But I'm going to sneak this up a little bit at a time, and we won't bore you with this. We'll do it Okay, as we go on, we're learning more and more about this. I've had the unit on for several hours, reforming the caps, and everything seems to be okay. Most of the receiver seems to be working. If I go in and touch the beginning of the IF chain here, well, now it's not doing it. I was getting a lot of response from this before. The audio amp's working. The BFO is working. The RF gain is working. The CRT is working. AGC is working. Noise limiter is working. You can hear differences when we turn the band switch, but we're not getting anything through the anything when I touch the antenna connector down here. It's absolutely no difference, and there's something obviously flaky going on in here. It sounds to me like a cap. At first I thought the local oscillator wasn't running because I was getting nothing down through the IF chain. However, the local oscillator is running, and I say the local oscillator, there's two on this unit. We have the 455 kilohertz line down here. A little investigation showed we have a 2 megahertz crystal right down in this corner. That 2 megahertz crystal is for the first IF. The first IF is 2 megahertz. Actually, it's 1.99 megahertz, but the crystal's cut for 2.05 megahertz. And if I put the scope down here on the chassis, and I just put the probe down here nearby the local oscillator, you don't actually have to couple to it in most cases. And we can probably see back there on the scope, we've got a trace. All I got to do is get near the local oscillator, and you can see the signal level comes right up. So the local oscillator, the 2 megahertz oscillator is running, but we're not getting anything into the IF chain from it. So that made me take a closer look, and can you see up there on the scope it's about 1.5 megahertz. It should be readable up on the top of the, come on, focus! It doesn't like to focus on the scope. See the 1.49 megahertz up there? This is supposed to be running at 2.05 megahertz, so I suspect that's a big part of my problem, is that local oscillator, first oscillator, is 500 kilohertz off, which would put any signals coming in the front end of this right outside of the passband for the IF. So I think that's going to be my next thing to investigate. Okay, and to sort of verify the fact that the IF chain is working, if I go to the output of the 455 kilohertz filter here, we can hear all the buzzing from the fluorescent lights. So that part of the IF chain's working. I'm just dumping right into the IF amplifiers. If I go to the front end of the IF filter, you can hear I'm still picking up the fluorescent lights. So the IF filter, the 455 kilohertz filter, is working. Now those lightning light discharges might be a bad filter, but I don't think so. It seems to be responding correctly. I think there's something up here in this oscillator chain, first local oscillator chain, that's breaking down. And again, I don't have the right schematic for this, so it's going to take some time for me to draw this thing out and figure out what I'm looking at. So I've got to contact the customer and see how much time he wants to put into this, what this thing is worth doing. And again, you can replace this whole thing today with a little unit that sits in your hand. I've got a 10 megahertz frequency reference that's GPS satellite locked to the Bureau of Standards, and it's within a couple of millihertz at 10 megahertz. This was the 1960s and 70s version of how to do that, and what you did is you injected a signal into the scope input in the front panel of this thing, and you look for the beat frequency on the CRT. You can inject, you know, frequencies that were multiples of WWV. For example, if it was a 10 megahertz WWV, you could insert a 1 megahertz signal, look for a 1 to 10 ratio. This is how calibrations were done way back in the day, by beating everything against WWV. And you can put audio frequencies in here too, at 400, 600, or a kilohertz, and look for the beat frequency on the CRT. Cool little piece to have working if you can get it working, but its value today is very limited. Still a nice piece of history, however. So I guess I'm going to go in here and there we go. If I go through that IF amplifier, you can see I'm getting through the 455 kilohertz chain. This is just an antenna, by the way. I'm just injecting noise into the system. If I turn the RF gain down, we can see the RF gain's working. I had the ALC on. With the ALC on, it overrides the RF gain. If I turn the automatic gain control off, so all the tubes, all the amplifiers are working, the whole chain is working. The problem is that local oscillator is running at 1.5 megahertz instead of 2 megahertz. And that puts the mixing frequency, instead of being at 455 kilohertz, it's 500 kilohertz low at this point. So it's completely outside the pass band of that filter. That might be it for tonight. It's getting late. I've got to get up tomorrow and work on the truck. I blew out an exhaust manifold gasket on the left-hand bank. I noticed it puttering a little bit on the way going to work the other morning, and now that I've driven on the highway a few times, it's starting to get pretty noisy. That's got to get fixed. And I've got other customer equipment to get across the bench here. Plus working 12 hours a day, plus taking care of my sister. So I think it's getting on now towards 10 o'clock at night. I'm going to go to bed and call it an evening. It's not a good idea working on this type of equipment when you're tired. You can get pretty badly hurt. Oh, and I was wrong about the dial lights earlier. I said there was 2 of them in there in case one went out. You could plug the other one in. I think somebody has modified those. There are 2 lamps in series, one of them just hanging from its socket. So it looks as if somebody put 2 lamps in series to reduce the illumination intensity, or to use whatever lamp they had on hand. I replaced the other lamp, and things are up and working. I don't know if you can see that. That one's lit, as is the front panel right now. The front panel window is lit. So that's taken care of. Actually, it picks off. It's an interesting setup. This appears to be an original resistor, and it's a fairly high wattage one, as it would have to be. It picks off the 6-volt AC filament line, puts it through a 15 ohm resistor to drop the panel illumination down, and somebody's put 2 of those pre-focused 1.5 volt old flashlight lamps, the ones that had a little lens in the tip of, oh, here we go, here's one right here. This is the dead one I took out. There's 2 of these in series. So actually 222, what's the voltage on that? That might be a 3-volt lamp. No, yeah, it might be a 3. I don't remember what a 222 is. Some of these were 1.5 volts, some of them were 3 volt. I don't remember which is which. Doesn't really matter. Other than that, this unit appears pretty much to be untouched inside. everything in here looks original. Everything looks factory. I see no evidence of any work ever having been done inside of this. It's a very nicely made receiver. I imagine this cost a pretty penny back when it was manufactured. I don't see any dates in here. It's really hard to date this thing. There's nothing on those capacitors. I can't find any date codes anywhere. This has to be probably no newer than late 60s, early 70s. I'm guessing. I really don't know. I don't know when these were manufactured. I only have a manual for a much older version of it. Like, you know, as I said, the one that's in the manual I have, or the schematic I have, has a 6x4 rectifier for the high voltage on the CRT and a 5Y3 low voltage for the rest of the circuitry. Very similar. A lot of the same tubes, and of course all the control function is pretty much identical, so you can get a pretty good insight on how the thing works. And I'm just kind of blathering on right now because I'm a little too tired, and I'm going to shut this down for the evening and call this one done. We'll pick this up in another video. I'm the Radio Mechanic. Hope I didn't bore you to death. One quick addition. Just before I shut it off, I just stuck my screwdriver in here and gave a couple things a tap. Listen to this. Every time I hit that resistor or this resistor, and they're tied together. No, I don't know. That's pretty. Yeah, I got to hit that much harder. Something in there is either loose or going open. Could be a bad solder joint. We'll figure it out. I'm the Radio Mechanic. See ya.